And last but not least, 3. Graph y equals 1 over x plus 2, x plus 4. You guessed it, this is a 3 shaper. Okay, there are 3 different spots. So, first things first, we want to graph the original function. Okay, the original y equals x plus 2, x plus 4. So I'm just going to get my graph here, and we have to do a little bit of side work with this one. Because this one right here, we know that we have x-intercepts at x equals negative 2. I should be consistent with the other videos. Let's graph it in red. The original, this one right here, and this one right here. Now I know that it opens up because there's no negative out in front, so it's going to be opening up like this. But we need to figure out where the vertex is. So when we are, shake off the dust of a few units ago. To find the vertex when you're given the factored form, you would say negative 2 plus negative 4 over 2. Negative 2 is one of our x-intercepts, negative 4 is the other one. So we're going to find the x value of the vertex. So we get negative 6 over 2, which is negative 3. So this right here is our x value of the vertex. Now we want to sub it into the equation to get our y value. So in the equation, y equals x plus 2, x plus 4. I'm going to sub in 3 for my x's, or sorry, negative 3 in for my x's. So y equals negative 3 plus 2 times negative 3 plus 4. So then y equals negative 3 plus 2 is negative 1, times negative 3 plus 4 is 1. So y equals negative 1. So the vertex of original is at negative 3, negative 1, which is pretty perfect. Okay, it fits the what we would guess, because we're noticing here there are no numbers in front here, so it's 1 and 1. So that means that there's no stretch factor. Say there was a 2 here, there would be a stretch factor of 2, because 2 times the coefficient of 1 that's in front of this x is 2. Or if we would say that this is 3 and this is 2, the stretch factor would be 6. But we don't have any of those things happening here. So we can just graph the original equation from the vertex. Over 1, up 1. Perfect. We know that those are on the lines. Okay. Over 2, up 4. Over 3, up 9. And so we're going to graph this function right here. Boop, 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 boop. Boop, 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 boop. And I'm going to be very careful and label this y equals x plus 2, x plus 4. You don't have to give it anything other than the factored form. Now, what we want to do now is we want to put in our vertical asymptotes where the x-intercepts are. So here's an x-intercept. I have a vertical asymptote here. And a vertical asymptote here. So what I want to do here is take my vertex and find the reciprocal of the y value. The reciprocal, this is our lucky day, okay? The reciprocal of the vertex, the y value of the vertex is still negative 1, so this is kind of like an invariant point, which is pretty cool. So that means that this open part is going to open down like that. And now what I want to do is I want to find out where these limbs equal 1. So this y equals 1 here, y equals 1 here, and we're going to use that to graph from. So this is asymptotic behavior here. And, oh, I should actually extend this out from my horizontal. Don't forget to do that. Don't forget like I did. And then we're going to go this way, getting asymptotically close to this line. This one too. Just like that. Now, here's the thing. What you could do, this is showing you the quick way of doing it. It shouldn't take that long to graph things. If you know how to graph the original one, you know the relationship between the x-intercepts and the vertical asymptotes. And knowing that to find this point here, you just need to find the reciprocal value of the y. Now we were lucky here that y equals -1, so 1 over -1 is simply -1. Now the other option here is that we could take all of our points. So this one would be -6, 8. And we could find the reciprocal function of saying 6, 1 over 8. Silly thing, it didn't copy in my negatives here. So -6, 8 can turn into -6, 1 over 8. Just as we can say -5, 3 can turn into -5, 1 over 3. Okay, and we can do it point by point by point by point like that, knowing that we have a vertical asymptote, or vertical asymptotes when we have y-intercepts. However, if you just find the reciprocal of that vertex and understand the general shape, and know where my y equals +1 and y equals -1, and then graph from the bounds of the asymptotes, that's a much quicker way than going point by point.